Hello, in this section in this video, I'll be going over 7.7, which is solve right triangles. So we know how to solve all of the sides of a right triangle. So this top little section is to find the angles. So let's say A is an acute angle. You can use the inverse of the functions to find the angles. So before it was like tangent of A is opposite over adjacent. So if we want to find what the measure of angle A is, you would do tangent inverse of opposite over adjacent would give you the measure of angle A. And you can do that for all three of the trig functions. So let's do an example. We want to approximate the measure of angle A to the nearest tenth of a degree. So we're looking for this angle here. What we're given is the opposite and the adjacent. So we're going to use tangent inverse, which is tangent with the -1 in the exponent area. Hold on, let me call this x. So x would equal tangent inverse of 10, which is the opposite, over the adjacent, which is 22. So you'll plug that into your calculator and you'll get x equals 24.4 degrees. Okay, number 2, this is our x, because that's what we're solving for. So x is going to equal, we have the adjacent side and the hypotenuse, so we are going to use cosine inverse. And the adjacent is 7, the hypotenuse is 12. So you're just going to plug that into your calculator and you'll get 54.3 degrees. Okay, next we want to solve the triangles. So that means we want to find all the missing sides and the missing angles. So for this triangle, we have R is 57 and ST is 15. So we can find measure of angle T pretty easily because all three angles of a triangle has to add up to 180 degrees. And since all of these are going to have a right angle, which is 90 degrees, that means measure of angle T would be 90 minus 57. So measure of angle T is going to be 33 degrees. Okay, so now we have to find the missing sides. So let's use tangent of 57. That'll give us RS. So here, let me label these. I'll call this X and this Y. So tangent 57 would be 15 over X, because it's opposite over adjacent. So then we would cross multiply and get X tan 57 equals 15 divided by tangent 57, and we get X equals 9.7. So here you have two choices. You can plug the two sides that we know, the 9.7 and the 15, into the Pythagorean theorem to solve for y, or you can use trig again. I'm just going to use trig again because I like using trig. So sine of 57 would give us 15 over y, and that's how we can solve for y. So we'll cross multiply, we'll get y sine 57 equals 15, and then divide both sides by sine 57. And we'll get y equals 17.9. And a way to check is that your hypotenuse should always be the longest side. So if you got 14.9 or something, that would be wrong because we were given that this is 15, so it has to be bigger than 15. Okay, next we have two side lengths, so we don't know any of the angle measures and we're missing one of the side lengths. So let's call the side x, the side y, and the side z. So since we're given two side lengths, I'm just going to use Pythagorean theorem to solve for x. So x squared plus 3 squared will equal 9 squared. So we'll get x squared equals, x squared plus 9 equals 81. So we get x squared equals 72. And then when we square root both sides, 72 breaks up into 36 and 2, and 36 breaks up into 6 and 6. So this I can take out of the square root and we have 2 left over. So we get x equals 6 rad 2. Okay, so now that we know this, we can also find y and z. So for y, I'm going to use 3 and 9, so that's going to be the adjacent and the hypotenuse, so that's going to be cosine. So cosine, y would equal cosine inverse because we're looking for an angle. So anytime you're looking for an angle, you're going to use the inverse of 3 over 9. And then once you plug that into your calculator, you'll get 70.5 degrees. And then for z, we can just do 90 minus 70.5. So that's going to be 19.5 degrees. Okay, now